Welcome to ESTCP's Training and Advanced Lighting Controls. This module is Code-Required Lighting Control Strategies. This module will be covering the topics of why do codes require controls, what codes and standards are used at the Department of Defense, what are the codes that are used in different states of the U.S., building codes as they're applicable to lighting controls, codes which are developed by ASHRAE, building code lighting control strategies, lighting controls networking, and exceptions to the code. If we need codes for lighting controls. According to the Energy Information Administration, lighting is the second biggest user of electricity in commercial buildings. Lighting accounts for 17% of electric use per the EIA's Commercial Buildings Energy Consumption Survey of 2018. The increased use of LEDs, lighting is an obvious target for energy efficiency measures. Building owners and managers may not voluntarily strive for energy efficiency. Thus, codes may be required to attain energy efficiency. Let's take a look at the quality. With increased energy reduction through lighting replacement and lighting controls, wattage from lighting decreases. A main goal of the standards and codes is to maintain and to enhance the quality of lighting despite the reduced lighting wattage. What is the difference between a code and a standard? Codes and standards are put in place to ensure the product, process, or service meets minimum capabilities and performance. Standards are developed to define the type and quality of a product or process. Note that a standard is not enforceable. It must be adopted into a code or law to be enforceable. Codes are laws. They are laws which are enacted by jurisdictions to ensure that the product or process meets the capabilities and performance noted in the standard. ASHRAE, formerly known as the American Society of Heating, Refrigeration, and Air Conditioning Engineers, ASHRAE writes many standards. The standard covering lighting is ASHRAE/Illuminating Engineering Society/American National Standards Institute 90.1, which is the energy standard for buildings except low-rise residential buildings. Henceforth, we'll refer to it as ASHRAE 90.1. Chapter 9 covers lighting. Again, note that a standard is not enforceable. It must be adopted in part or as a whole in a code or a law. The International Energy Conservation Code, IECC, is the energy code for construction. The IECC references ASHRAE 90.1, requiring construction meet the type, grade, and quality in ASHRAE 90.1. Again, please note that codes or laws are put in place by jurisdictions to ensure that capabilities and performance based on standards or guidelines. The Unified Facilities Criteria is the code used for construction at defense facilities. These codes are prescribed by the Military Standard 3007. The UFC is effective upon the issuance of the code and is distributed by the Home Building Design Guide. Document 1200-02 is the Department of Defense Construction Code. Document 3-53001 covers interior and exterior lighting systems and its controls. UFC 3-530-01 covers interior and exterior lighting systems and controls. Chapter 1.4 of UFC 35001 states that work must meet the ASHRAE 90.1 standards. For UFC 1-200-02, which is the DoD construction code, Chapter 2.3.11 covers commercial and multifamily residential high-rise construction. Chapter 2.3.1.2 is on low-rise residential, 3 stories or less. ASHRAE Standard 90.1 is updated on a 3-year cycle. Chapter 9 covers lighting. The IECC code is updated on a 3-year cycle as well. Section C 405.2 is on lighting. For defense facilities, the UFC is used. UFC 3-53001 is the design and performance criteria for interior and exterior lighting. UFC 1-200-02 is the building code reference. At Department of Defense facilities, per UFC 35301 of December 2023, and per UFC 1-200-02 of June 2022, commercial and high-rise residential are to meet the requirements of ASHRAE 90.1 edition 2019. Low-rise residential are to meet the requirements of the IECC 2021. We look at this slide as some of you may be from a civilian background, and some of you may work with contractors who only have civilian experience. All of the states other than those in the black adopt or reference ASHRAE 90.1 as their state energy code. As you see, there are a variety of ASHRAE iterations referenced, at least 5, from 2007, 2010, 2013, 2016, and 2019. The 22 ASHRAE version is published, but it will take jurisdictions time to adopt that issue, and there will then be more than 5 versions of ASHRAE standards being referenced. The states in black either have home rule, and so each city or town may have its own code, or there is no state energy or building code. With the UFC, the above confusion is eliminated, as there is one code and it's one reference ASHRAE standard, which is used at all DoD facilities nationwide. In UFC 3-530-01, Chapter 2.2 covers interior lighting controls. Chapter 4.3 covers exterior lighting controls. 2.2 covers daylighting controls, where lighting illumination level changes with the amount of daylight. Means of egress, which defines the illumination needed for egress areas. Strategies covering the different controls available. Network certification defining what is acceptable for networked lighting controls. For exterior controls, strategies covering the different controls available, and again, network certification. Chapter 9 of ASHRAE 90.1 is on lighting. Guidelines for interior lighting controls are in Section 9.4 of ASHRAE 90.1. Subsections are as noted in this slide. Local controls, restricted to manual on, restricted to partial auto on, bi-level lighting control, automatic daylight controls for side lights, automatic daylight controls for top lights, automatic partial off, automatic full off, scheduled shut off, and scheduled off during non-business hours. Recall that ASHRAE 90.1 is for commercial and residential high-rise. Controls for occupancy sensors are required in many building or area types in the IECC. They include classrooms, training rooms, conference meeting multi-purpose rooms, copy rooms, lounge areas, enclosed office spaces, open plan offices, restrooms, storage rooms, locker rooms, warehouse storage rooms, and other spaces 300 square foot or less. In C405.2, there are time switch controls which are required where they're not occupant sensors unless automatic shutoff poses endangerment to occupancy, safety, or security. There are light reduction controls which make it possible to reduce lighting by more than 50% uniformly. This usually entails switching rows or alternate lamps off. There are codes which are starting to move towards dimming. Daylight responsive controls are used to try to reduce the mechanical use of lights. Daylight controls are based on lighting power density in watts per square foot. And manual controls are used for backup to automatic lighting controls and for exceptions such as small square footage or safety. In this table, we note where corresponding lighting control strategies are found in ASHRAE 90.1, the IECC C405.2, and the UFC 03-530-01. So if you're looking for daylight control requirements, where to reference in IECC, you will note that's under Section 2.4 of C405. If you're looking in ASHRAE 90.1, you'll see that it's in Chapter 9.4.1.1, Sections E and F. The appendix of the UFCs often have practical information about the products covered in the code. Appendix A5 provides important useful information on control approaches. Occupancy-based controls are ideal for areas where individuals have their hands full when entering or leaving a space. Bi-level switching and multi-level switching allows for lamps in a fixture to be switched independently to be, for example, 50% in a 2-lamp fixture, 33%, 66% in a 3-lamp fixture. Light level tuning allows for adjusting the maximum light level to precise requirements. Theme-based dimming allows for multiple lighting zones to go to a level with one button touch. Manual switching is ideal where automatic control is not allowed, such as in an electrical room. Time clocks adjust based on the time of day. Personal control gives an individual occupant the ability to control lighting in their space, even in an open office area. And network control systems are where the lighting is integrated wired or wirelessly. Appendix 7 refers one to the American National Standards Institute, Illuminating Engineering Society's Lighting Practice 6, which provides valuable information on system architectures, topologies, and protocols which are essential to lighting controls. As noted in a previous module, some of the hesitancy to adopting advanced lighting controls is due to the many different controls protocols used by controls manufacturers. This problem is evidenced on this slide. There are at least 15 different protocols used for controls communications. The previous publication of UFC 3-53001 referenced one to Technical Memorandum, the Aluminum Engineering Society's TM23-11. TM23-11 is invaluable in summarizing system architecture, topology, protocols, and commissioning of lighting controls. In wrapping up, we have covered that a goal of codes and standards is to reduce the large electrical use of lighting. Standards are guidelines which may be adopted for use in codes. The United Facility Criteria is one code used for DoD facilities nationwide. And the UFC adopts the IECC Code 2021 and the ASHRAE Standard 90.1 2019. Thank you for viewing this module on lighting controls. We hope to see you on future modules.